Hello everyone, I hope you're all safe and sound. This is Abhishek Gupta, and in this video I'll be discussing about the definition and classification of a transducer. So let's get started. So what is a transducer? Transducer is basically an electronic device that converts one form of energy into another form, and this process of conversion is known as transduction. Whereas electrical transducer may be defined as a device that converts a physical quantity into an electrical signal. Pickup is the another name for a transducer. There are so many examples of transducers such as pressure gauge, temperature gauge, ultrasonic transducer, LVDT, strain gauge, piezoelectric transducers, etc. So I'll be discussing about these type of transducers in the coming videos. So let's have a look on the basic block diagram of a transducer, which basically consists two important elements. First is sensing element and next is transduction element. So the physical quantity which is being measured is first applied to the sensing element, and this sensing element is nothing but a sensor which is responsible for detecting any change in the physical quantity, whereas transduction element basically converts the sensor's output into an electrical signal. So the physical quantity which is basically a non-electrical quantity, it is converted into an electrical signal with the help of these two elements, that is sensing element and transduction element. So here are the advantages of electrical transducer. First is the electrical amplification and attenuation can be done easily. The effects of friction are minimized. It can be controlled with a very small power level. The mass inertia effects are minimized. It is highly accurate, and last but not the least, the electrical output can be easily used, transmitted and processed for the purpose of measurement. So here is the classification of transducers. First, on the basis of principle of transduction, it is classified into three categories. First is variable resistance type transducers. Second is variable inductance type transducers. Third is variable capacitance type transducers. Next, on the basis of output conversion, it is classified into primary and secondary transducers. Next, on the basis of power source, it is classified into active and passive transducers. Next, on the basis of output, it is classified into analog and digital transducers. Last is the transducers and inverse transducers. So let us discuss these type of transducers. First is variable resistance type transducers. The variable resistance type transducers work on the principle that the resistance of the conductor is directly proportional to the length of the conductor and inversely proportional to the area of the conductor. So the basic formula for resistance is given by R equals to rho L by A, where R is resistance, rho is the resistivity of the conductor, L is the length of the conductor, and A is the cross section area of the conductor. So by varying any of the variables, we can get these type of transducers. There are so many examples of these type of transducers, such as potentiometer, resistance thermometer, strain gauge, thermistors, etc. Next is the variable inductance type transducers. These type of transducers works on the principle of variable inductance. That is, inductance can be varied in the following manners. First is change of self-inductance. So formula for the self-inductance can be given by L equals to N square by R, or it can also be written as L equals to N square mu G, where N is number of turns, R is the reluctance of the magnetic circuit, mu is the permeability, and G is geometric form factor. So we can get vary the self inductance by changing any of these variables, that is N, mu or G. Next is change of mutual inductance. The formula for mutual inductance can be written as M equals to K square root of L1 into L2, where K is coefficient of coupling and L1 and L2 are self inductance of two coils. So mutual inductance can be changed by varying self inductance of the coils, or it can also be changed by changing the coefficient of coupling. And last is production of eddy current. We all know that when a conducting plate is placed near a coil carrying AC current, a circulating current is induced in the plate, which is called eddy current. which in turn produces its own flux, which try to reduce the flux of the coil carrying the current, and hence the inductance of the coil changes. So nearer the plate is to the coil, higher will be the eddy current and lower is the inductance, and vice versa. So by using any of these discussed methods, we can simply vary the inductance and we can get a variable inductance type of transducer. This principle is widely used in so many applications such as displacement measurement, force measurement, pressure measurement, velocity, torque, acceleration measurement, etc. Next is variable capacitance type transducers. We all know that the capacitance between two parallel plates is defined by the following formula, that is C equals to epsilon A upon D, or it can also be written as C equals to epsilon R epsilon naught A upon D. Whereas C is the capacitance of the parallel plates, epsilon is the absolute permittivity, epsilon naught is the permittivity of free space, epsilon R is the relative permittivity, A is the effective area of the plates, and D is the distance between the plates. So by changing any of these variables, we can get a variable capacitance type of transducers. This principle is widely used in many applications such as to measure linear and angular displacement, pressure, force and torque measurement, flow level and humidity measurement, etc. Next is primary and secondary transducers. Primary transducer is the sensing element which responds to the change in physical phenomena, or it converts the physical quantity into mechanical movement or displacement. Examples are Bourdon tube, diaphragm, bellows, etc. Whereas the secondary transducer converts the output of primary transducer, which is mechanical movement or displacement, into electrical output. Examples are LVDT, strain gauge, etc. Next is active and passive transducers. The transducer which does not require any auxiliary power supply to produce their outputs are called active transducers. This does not imply that there is no need for power at all. In actuality, the energy needed for operation comes from the physical change itself. The examples of active transducers are photovoltaic cell, thermocouple, piezoelectric crystals, etc. And the transducer which requires an auxiliary power supply to provide their output is referred to as passive transducers. Examples are thermistor, strain gauge, RTD, etc. Mostly the transducers are passive in nature. Next, analog and digital transducers. Analog transducers are defined as devices that provide outputs in analog form or as a continuous function of time. Examples are strain gauge, LVDT, thermistor, RTD, etc. Whereas digital transducers are those transducers that generate outputs in the form of pulses or digital data. Examples are shaft encoder, digital tachometer, turbine meter, etc. Last is transducers and inverse transducers. As already I have discussed, transducers are measuring devices that take non-electrical variables and turn them into electrical variables. Examples are RTD, strain gauge, LVDT, etc. Whereas a measuring device which converts an electrical quantity into a non-electrical quantity is known as inverse transducers. Example is piezoelectric crystal. So this is all about the transducers. Thank you.